In this video, we're going to take a look at a couple more advanced distributive property problems. Now, the first one is going to be a little bit more advanced distributive property, and then the next one is going to be a more advanced factoring problem. Again, factoring is nothing more than distributive property, but shh, don't tell anybody that. So, let's review it just a little bit. Distributive property for any real numbers a, b, and c, a times the quantity b plus c says that you distribute the a and multiply it through on the b and the c to give you a times b plus a times c. So let's see if we can go ahead and use that down here. Seem to have an issue here because we have 2 terms there and we have 3 terms there. Well, let's see if we can work around that. Remember, as you're working with addition and subtraction and multiplication, more addition and multiplication, but you can kind of jury-rig it for subtraction and division, you have something called the associative property. I mean, the associative property says if you have a plus b plus c and you associate a and b, then you can reassociate and say this is really a plus b plus c, and you can reassociate the addition that way. Well, you can kind of, since you can't add 3 numbers together at the same time, only 2, you can just say, well, if I'm given a plus b plus c, I can then choose which pairing I want to use. So I could use that pairing, I could use this pairing, I could even rewrite it using the commutative property and say that it's going to be b plus a plus c. So 3 different ways you can look at it. All right. So we're going to use this idea of the associative property to go ahead and see if we can't reassociate. Taking a look at 4x plus 3y minus 9, let's go ahead and associate these first 2, and then we'll leave the negative 9 by itself. If we do that, then we really have one term or group here and the second term here, which means we satisfy the b plus c. B is the number 4x plus 3y. C is the number negative 9. So I'm going to pick up my negative 3 and I'm going to distribute that negative 3 to both that first term and that second term. And I'm not going to just do it out though. I want you to see where this leads. So it's going to be negative 3 times the quantity 4x plus 3y minus negative 3 times 9. I'm going to put parentheses around that just to tell us that we have to do that first. Now, before I expand this, I don't want to expand or combine the negative 3 and the 9 yet. I want to go ahead and notice that I've got 2 terms inside of parentheses, or in this case brackets, which are the same thing. And I have a number out front, which means I can distribute that negative 3 to both the 4x and the 3y. So I take negative 3 times 4x plus negative 3 times 3y minus negative 3 times 9. Notice that the end result is that I've distributed my negative 3 to each of the 3 terms. Using this exact same technique, you can expand it. You can extend this into as many terms as you want. So, if I complete this out, I really have negative 12x minus 9y plus 27. And so what we can do then from this is we can take away that negative 3 times the quantity 4x plus 3y minus 9. All I have to do, gather up my negative 3, distribute it to each of the 3 terms. If you have 4 terms, distribute it to all 4. That gives us negative 12x minus 9y plus 27. So as you can see, the distributive property doesn't simply restrict you to only one number being distributed into 2 terms, but you can have perhaps 2 terms distributed into 2 terms, or 5 terms distributed into 5 terms. More on that later when we hit polynomials. Likewise, the distributive property, it doesn't restrict you necessarily to just two terms in the distribution. It also allows you to factor more than two terms using that same principle. Okay, so we could work backwards here and I'd say, okay, associate these two and go back, but we're not going to do that. I'm just going to show you how to do it. And so we have to find the greatest common factor of -4, 8, and -2. And we're really not going to look for the negatives. We're really just going to hit the greatest common factor of 4, 8, and 2. Now, you might say, oh, wow, I saw your other video, or I saw another video where this guy used his calculator to find it. Sweet, so let's go ahead and do that. So we take math over to num. This is for the 83 and 84. If you go down to option number 9, it's GCD, which is greatest common divisor. It is the same thing as the greatest common factor. So we hit 4, 8, 2. We're like, yeah, sweet, we can, oh. Well, that's no fun. So we'll quit. So, well, why won't it do it? Yeah, bad news. Your calculator cannot find the greatest common factor of 3 numbers. It can only find the greatest common factor of 2 numbers. So to get around this, we can do one of two things. We can either do this by hand, which is fine, these numbers are small enough, or we can nest it. It can be shown, I'm not going to show it here, but it can be shown that if you find the greatest common factor of 3 numbers, what you really do is find the greatest common factor of the greatest common factor of 2 of the numbers and the third number. So if we were to go back to our calculator, we could go second entry to get that back and say, instead of doing that, hit insert math num 9. And then we'll insert another set of parentheses. So we say, well, find the greatest common factor of 4, 8, and 2. You find the greatest common factor of the greatest common factor of 4 and 8 and 2. Enter. Oh, now it works. So we can nest it like that. By the way, the greatest common factor of 4 and 8 is 2. I'm sorry, is 4. So the greatest common factor of 4 and 2 is 2. So now that we know it's 2, we pull that 2 out, but because we have a negative, we automatically pull a negative out front. And we just go through and divide. -4 divided by -2 is a positive 2x. Positive 8 divided by -2 is a -4z. -2 divided by -2 is a positive 1. And that's it. And that's how you work through it. So it's really not that bad. Just to remember, the distributive property is not limited to just 2 terms inside that set of parentheses. You can have as many terms as you want inside and outside. We'll leave the outside for another day.